Good morning. Good morning. Today we'll continue our course pharmaceutical calculation. The topic we are entering today is density, specific gravity, and specific volume. Density, specific gravity, and specific volume. As a science student from your secondary school, you came across density, right? In your physics, right? Good. You came across density in your physics. You also came across this specific gravity, but not this name. It was that they gave it then. But let's start with density. What is density? Benita Oya, what is density? You don't know. Try. What is density? Are you serious? What is density? Mass per unit volume. Good. So when you come with density is just ratio of mass to what? Volume. So mass over what? Volume. Mathematically, mass per unit what? Volume of a substance. So if you have a substance now, and you know the mass of that substance, and you know the volume the substance occupies. So if you divide the mass of that substance with the volume of the substance, you get the density of the what? Substance. So in a nutshell, you know, mass of a substance is constant. True or false? Does mass change? Does mass change? Mass of a given substance is constant. True or false? Good. So, but weight can change. Can change depending on the what? Location. True or false? Because G is not the same thing everywhere. So, but mass does not change. Mass of a particular substance, the quantity of mass of a particular quantity of a substance doesn't change, it's constant. So if that is the case, that means density is inversely proportional to volume. True or false? True or false? Why mass is the what? Constant. So we can comfortably say that density is what? Inversely proportional to what? Volume of a substance. True or false? Why mass is the what? Constant. Why mass is what? Constant. So, density is the mass per unit volume of a substance. It's usually expressed. What do you think should be the unit here? Meter. Who say meter? Gram per what? Millimeter. Is it like gram per millimeter? Gram per what? Gram per what? cm cube. But you know that these things, by the time we enter concentration, you begin to appreciate this unit. I'm not complicating. This has different things, different other units that talking about amount per unit what? Volume. Are you aware that this is also, by the time you enter concentration, you realize that this is also a concentration term. True or false? Because concentration is what? Amount, but this amount here is now a mass. Mass. You know, amount can be in mole, it can be in what? Mass. True or false? That's why you have mass concentration. Molar what? Concentration. When it's in mole, it becomes molar what? Concentration. But in a nutshell, this is a concentration term. You can still see gram per ml. True or false? Ml is also a unit of expression of what? Volume. True or false? Volume. In fact, remember our last class, we said that this is cubic what? This is that cc people are talking about. Three of us, we discussed it. Cubic what? Centimeter. Instead of using cc, use what? Cm cube. Now, 1 mil is something with what? 1 what? Cm cube. That's why we discussed this now. I told you that if you go to pharmacy or go to hospital and they tell you to bring 5 cc syringe, they're talking about what? 5 mils syringe. Now let's continue. So density is usually expressed as gram per cubic centimeter. Even though they use cc here, but I told you that is not a standard what? Unit. Am I communicating? It's not a standard unit. So instead of using cc, use what? Cm cube. Now, what do you understand by the term gram? Gram is defined as the mass of 1 cm cube of water at 4 degrees Celsius. Gram can be defined as the mass of 1 cm cube or 1 cubic centimeter of water at 4 degrees Celsius. So if water is at 4 degrees Celsius, you get 1 mil of that water or 1 cm cube of that water, as case may be, at 4 degrees Celsius. You get 1 cm cube of that water or 1 cc cube of that water. The weight of that water gives you what the value of what? Gram. Am I communicating? That's what this definition is trying to let you know. Now, but for the purpose of what we are doing, they now, according to USP now state that 1 mil of 1 mil may be used to be equivalent to what? 1 cc. That is according to USP, 1 mil can be used for what? 1 what? Cubic centi, 1 cm cube. Am I communicating? 1 cubic centimeter. That's why here, pharmaceutically, they will use more of mils than just cm cube. Am I communicating? We use more of mils than what? Cm cube. So note this point. So if that is the case, density of water may be expressed as just 1 gram per mil. So you can simply say gram per what? Mil. That's why, remember I told you that this thing and this thing are talking about the same thing. Am I communicating? Because USP said that this can be equivalent to what? 1 mil. So this is also a unit of what? Density. Which is also a concentration what? Terms. Which is also a concentration what? Term. But in your chemistry, you see more of cm cube, 3 of us. Cm cube or dm cube. Of course, you know the relationship between dm cube and cm cube, right? You know, right? Good. Now, 1000 cm cube make 1 dm cube. 1000 cm cube make 1 dm cube. Now let's continue. So generally, you can say that density is simply mass over what? Volume. Density is what? Mass over what? Volume. Now, so let's assume that we have that 10 mil of sulfuric acid weighs 18 grams. What would be the weight? What would be the density of the sulfuric acid? If 10 mil of sulfuric acid weighs 18 grams, what is the density of sulfuric acid? Huh? You don't know. Hello, this is not a good spirit too. If this spirit of I don't know is a bad spirit to learning. It negates learning. You may think you are doing well by saying you don't know. You're not helping yourself. If you ask question, I don't know should not be the first thing to say. Give it a try. Before you conclude that you don't know. Don't even say you don't know. try to see, keep trying. That is how to read. They're not like I don't know. Please, I don't want to be hearing that thing from you people. If you ask a question, I don't know. It's somehow. It's somehow. What I've already said here now, I said density is mass per volume. I ask question here and now. A human being is telling me I don't know. Does it make sense? You go through what you have put down, say, sir, excuse me, give me some minutes. You go through what you have put down, try to solve it. That is the spirit of learning. They have to learn. Even if I ask question here and you have not heard about it before, you have your phone. If you never have phone, you look for a way to see how you can browse it. Don't say you don't know. It's wrong, please. The word of today about they're not like I don't know the word of today. Before you enter any class, make sure you have your phone, make sure you have your data. What will you spend your data on? Have you have your data with you? When a question is asked, don't say I don't know. Say, sir, give me some time. Check it up. If you keep talking, if you behave like this, it becomes part of you, your patient will run away from you because they come to you with problems. They want to solve your problem. They look at you, someone that will help them. You come and you say, I don't know. Will you come again? No. I say, ma, please, just give me some minutes. Let me take it up. It's also act of humility. Give me some minutes. Let me take it up. There's nothing wrong there. No matter how intelligent you are, give me even me today. Give me some minutes. Some people will call me on phone, ask some questions. Give me just a few minutes. I'll get back to you. They're not like I don't know. It's arrogance. You think that you're doing, but that is a sort of arrogance in a way. Yes, I don't know. Yeah. Say, I don't know. Tomorrow they will not come again. They will run away from you. They say you're not serious. Please, let us not build a habit now so that it not become an attitude for us. But what you build on a daily basis, you think as you are doing it, it's becoming part of your life. To listen that you won't even know when you are dishing it out unknowingly. It becomes an attitude that will be difficult for you to stop. Please, let's kill that spirit, please. I'm seeing that spirit hovering over some of us this morning. Let's kill it before it becomes part of us. Now let's continue. So now, as I say that you have that density, if the 10 ml of sulfuric acid weighs 18 grams, what is density of sulfuric acid? That's the question. 1 point what? So how did you get it? Good. The weight, the mass is what? 18 grams. Then the volume is what? 10 ml. So you have 1.8 gram per ml. All right. So now let's continue. This is what specific gravity. Density is all about. This is the most issue now. I'm entering specific gravity. So from specific gravity now, we'll start seeing the application of what? Density. You start seeing the application of density. This one is the one you know. We are starting from the known to the what? Unknown. This has a lot of application in determining specific gravity and what? Specific what? Volume. This one has a very important pharmaceutical implication. But by the time we treat it, you appreciate it better. Now let's go. Let's look at specific gravity. Let's look at specific gravity. Now, what is specific gravity? The symbol for specific gravity is SP what? Good. This thing. Okay, Nyam rag. Is there any rag here? Because this thing is messing the board up. Instead of cleaning it, it's compounding our issues. Rag or toilet tissue is okay. Why? Toilet tissue have this mob don't suffer for your hand. Or you clean it. All right, now. Specific gravity, we have SP what? Yeah, this is symbol. This is the symbol for specific gravity. Now, unlike density that has units, specific gravity is a perfect ratio. It has no units. Am I communicating? It has no units. It has no units. So that's one thing I want you to know. That means it's dimensionless. It's dimensionless because it has no units. Now, it is expressed decimally. No units, ratio, no unit, dimensionless, expressed decimally. Expressed decimally. So what is specific gravity? Is what? Ratio of density of a substance. Density of another substance. Yeah, using like that physics related density of yeah. Yes. She grabbed the point. If you know your physics very well, if you did your physics very well, you did relative density. This is pointing towards that. But here we call it what? Specific gravity. So, yes, I know that they have some relationship, but let's focus on the name we are using here now. Specific what? Gravity. Basically, specific gravity of a substance is the ratio of the weight of the substance to the weight of equal volume of water. Am I communicating? Density of a substance, or when you say water, there's something I want. Hey, there's something I want to point out. There's something I want to point out. In determining specific gravity, some standards are used. There are two major standards used in determining specific gravity. There are two major standards used in determining specific gravity. They use hydrogen and water. Am I communicating? Hydrogen and water. Basically, I want to give a universal definition. When I say water is specifically talking about determining specific gravity of liquids and solids. Water is specifically a standard used to determine specific gravity of what? Liquids and solids. But hydrogen is a standard used for determination of specific gravity of what? Gases. Note this point. So if you ask a question, I gave a definition, but I remember that this is not just about solid and liquid. What of gases? That's why I say that I started talking about the standards. General definition of specific gravity without reference to any state of matter, without reference to any particular state of matter. General this thing for specific gravity is that specific gravity is defined as the weight of substance, the ratio of weight of substance to the weight of equal volume of a particular what? Of a particular what? Standard or substance regarded as the what? Standard. Specific gravity of a substance is defined as what? The ratio of the weight of a substance to the weight of equal volume of a what? Of a standard. So that standard can be water, it can be what? Hydrogen. So if you are asked now to what is the, maybe they ask you now, they get something like oxygen as a gas now, and you are asked what is the specific gravity of a gas or oxygen. Okay, let me start with a gas. Define specific gravity of a gas. Specific gravity of a gas is the weight of that gas, ratio of the weight of that gas to the weight of equal volume of what? Hydrogen. Because hydrogen is the standard for gases. I gave a general definition of that specific gravity is ratio of the weight of a substance to the weight of the equal volume of a particular what? Standard. That standard can be Hydrogen, it can be. You know we have how many states of matter? 3, solid, liquid, and gas, right? So that standard can be hydrogen, which is used for gases only. It can also be, that standard can also be what? Water, which is used for what? Liquid and solid substance. So the 3 states of matter are covered now, right? So if you are asked what is the specific gravity of a gas, you can say that specific gravity of a gas is the weight of that gas, the ratio of the weight of that gas to the weight of equal volume of what? Hydrogen. If they mention a particular gas, if they name the gas, say oxygen, what is the specific gravity of what? Oxygen. You can simply say the specific gravity of oxygen is the weight of what? Oxygen. Ratio of the weight of what? Oxygen to the weight of equal volume of what? Hydrogen. That is for gases. Now, maybe you are asked what is the specific gravity of a solid. You simply say is ratio of the weight of that solid to the weight of equal volume of what? Water. Or maybe you are asked the specific gravity of a liquid. You can simply say is ratio of the weight of the liquid in question to the weight of equal volume of what? Water. Let's assume they ask you the liquid is kerosene. You are asked what is the specific gravity of kerosene. You can simply say the specific gravity of kerosene to the what? Weight of equal volume of what? Water. This is what specific gravity is all about. Now, where confusion normally comes, what is that? What is the meaning of that? You can simply talk of the weight of substance, right? What is the meaning of weight of equal volume of a standard? What does it? Let's use liquid. Let's use water as example now. What is the actual meaning of weight of equal volume of water? What do you understand by weight of equal volume of water? What do you understand by weight of equal volume of water? Because that is where the confusion starts. What is the weight of equal volume of water? Now let me explain. I know why I'm explaining it because this by the time we enter calculation now, this thing brings confusion. So I want to explain it on time before we enter calculation. Now when you hear, okay, any idea? Yeah? Density of water, weight of equal volume of water. No, when you say weight of, you're comparing two things now. You're comparing the water and that substance. So if you say weight of equal volume of, now let me now if you get, for those of you that have provisions in your room, that tin of peak milk, powder peak milk, now if you get 2 of them, they have the same volume, right? 2 of them have the same volume, right? Now, yes, right? Good. Let's assume that what we fill the two tins. Let's assume, I don't know how many mil it is. Let's assume is 50. Let's assume is 500 mil. Let's assume is 500 mil. Or it should go to 1 liter, right? Let's assume it's 1 liter that can fill the 2 of them. Let's assume, I'm not sure. Let's assume it's 1 liter that can feed 2 of them to the brim. They have the same volume, right? Good. Now, you now pour only water in one water, fill it, cover it. Then get sand, pour in the other one, cover it, right? Do they have the same volume? The sand and the water in the 2 tins, are they of the same volume? Yes. They occupy the same space. So they are the same what? Volume. But would they have the same weight?
No.
They will not have the same weight. The one that contains sand, despite the fact that they have the same volume, 1 liter, 1 liter. But the one that has sand, the weight will be more, right? Than the one that has what? Water. So even though 2 of them occupy the same volume, but their weight is not what? The same thing. True of us. Good morning. Now, when you hear weight of equal volume of water, This is 1 liter of sand. This is 1 liter of water. Equal volume. Equal volume. Am I communicating? Equal volume. So this substance now, this substance now and water have the same volume, but they don't have the same weight. Let's assume that the weight of this one is, let's say, is 1 kilogram, and water here is 0.5 kilogram. They have the same volume, but they don't have the same weight. This is equal volume of water. So weight, that substance, that sand in question, the sand in question has weight of 1 kilogram. So weight of equal volume of water for this sand is what? 1 kilogram. Because this is the weight of the sand that have this equal volume with what? Water. So weight of equal volume of water is the weight of that substance that have the same volume with what? Water. So the weight of this sand that has the same volume with water is what? 1 kilogram. So if you want to really find the density, the specific gravity of this water, now so the sand, you are given a particular weight of sand, and you are given a sand and says you find the specific gravity of the what? Sand. What you do is this: simply divide the weight of the sand, right? Weight of what? The sand over weight of equal volume of water. So the weight that has the same volume with water is what? 1 what? Kilogram. Am I communicating? This gives you the specific gravity of this sand. If you're not careful, you think that the weight of equal volume of water is talking about weight of what? Water. It's not talking about what? Weight of what? Water. It's talking about weight of that substance. But the weight of that substance that has the same volume with what? Water. Any question? Ask. If you have a question, ask. Feel free.
So, for example, like in a question.
Yeah.
This 1 kg will be given.
That's how. Don't worry, but that this. It will not be given to you straight. Say, okay, weight of equal volume of water is 1 kg. No lie. You are the one to get it yourself from the question. Am I communicating? That's why I'm trying to explain it here. You will not see in the question, weight of equal volume of water is 2 kg. No. That's why I'm trying to make you understand it, so that if you see a question, you know exactly how to go about it. Is it clear? Is it clear now? So what I want to point out here is that if you hear weight of equal volume, some people confuse it. Some people think that he's talking about weight of water. No, it's weight of that substance you are in question that has equal volume with what? Water. Just if you understand what I did here, it's easy. Is it clear? Now let's continue. Look at this question. Look at this question. It's because I say, if 10 ml of sulfuric acid weighs 18 grams, if 10 ml of sulfuric acid weighs 18 grams, you want to go okay? Are you okay?
Yes.
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 If 10 ml of sulfuric acid weighs 18 grams and 10 ml of water under similar conditions weighs 10 grams, what is specific gravity of sulfuric acid? If 10 ml of sulfuric acid weighs 18 grams and 10 ml of water under similar conditions weighs 10 grams, what is the specific gravity of what? Sulfuric acid. Remember the definition. Here now, we are sulfuric acid here. Is this solid or liquid? Liquid, right? Then, so the standard here is what? water, right? So that means specific gravity of sulfuric acid is weight of sulfuric acid. So specific gravity of sulfuric acid. What is the IPAC name of sulfuric acid? What is the IPAC name of sulfuric acid? Ndị chemistry ngwa. Huh? Tetrawetin. Tetrawetin. Who my sister? Now, so specific gravity of sulfuric acid is equal to what? Weight of what? Sulfuric acid over weight of equal volume of what? Water. Now we are going to find the specific gravity of the what? Sulfuric acid. Now from the question, which one is the weight of sulfuric acid?
18 grams.
18 grams. 18 grams, right? So here is what? 18 what? Gram over weight of equal volume of water. What does it mean? The volume? No, the weight of sulfuric acid that has the same volume with water. Okay, now it means weight of sulfuric acid that have the same volume with what? Water. If you look at the question, what is the volume of sulfuric acid? 10 ml, right? Good. What is the volume of water? 10 ml, right? Right? Yeah. Talk now. Huh? Look at the question. Look the confusion has been started. You know. I said it. Just look at the question again. Let's go back to the question. The question says, if 10 ml of sulfuric acid weighs 18 grams and 10 ml of water under similar condition weighs 10 grams. Weighs 10 grams. The specific gravity of the acid is what? What do you mean of that 10? That 10 grams means what? Is it the weight of sulfuric acid that have the same volume with water? Or is it the weight of the water that has the same volume with sulfuric acid? The weight of the water that has the same volume with water. The weight of sulfuric acid. But we are told here that 10 ml of sulfuric acid weighs what? 18 grams. Look at. They have the same volume, right? They have the same volume, right? But that 10 ml for sulfuric acid is weighing 18 grams. While 10 ml of water is weighing what? 10 grams. So which one? No. Between two of them now, which one is heavier? It's heavier, right? It's heavier, right? Good. So if sulfuric acid is heavier, now the weight of sulfuric acid given to us is what? 18 grams, right? Now what should be under this place? Is it 18? Or is it 10 grams? Who will help us? What are you doing? Okay, you go them. Okay, sorry. No, just say it. Let's hear you. See, let's hear it. Say it. No problem. I'm listening. Okay, continue.
Some of them have the same thing. So, from what you said in the last question, we are checking the volume of the water, the volume of the sand. So in this one, I think it's not the volume of the water, it's the volume of the sulfuric acid that has its equal volume with water. The weight of sulfuric acid has the equal volume with water. Since two of them are telling me what should be under test 18.
18 grams.
Yes.
And under idea. Under idea. What is it? 10 grams. She saw it in the example. Now, this thing, if you're not careful, this simple thing you're saying here, if you're not careful, you need to be really careful solving question with this thing. Let's look at this thing again. Weight of equal volume of what? Water. Weight of equal volume of what? Water. Now, are we dealing with weight of water here? This weight of water that has the same volume with sulfuric acid. Are we dealing with weight of the sulfuric acid that has the same volume with what? Water. You know we are comparing with a standard. Remember, right? We are comparing with what? A standard. The point that two of them must wait. Am I calculating? The numerator, the main point you should know that the numerator and the denominator must be in what? Weight, not volume. Now, but the weight, the one on top is the weight of the substance you want to determine its what? Specific what? Gravity. Now here, should it be weight of the substance that have equal volume of water, or should it be the weight of the water that have equal volume with the what? Substance? You know what we say it's a ratio. It's a ratio, right? I want to break these misunderstandings so you understand it. If you understand it from this, where I'm coming from now, you can grab it for life, no confusion. Listen carefully. I love this. I said, here, this is the, yes, I agree. I said this. Good. She said this. But let's look at it critically. We said it's a ratio, right? We are comparing with a standard, right? We are comparing the substance with a standard, which is water in this case. Am I communicating? Now, what is top here is 18 grams, we know, which is the weight of the what? Substance. Go. Now, this 18, the one that should be under here, should it be the weight of the same substance that have equal volume of water, or weight of this standard you are comparing it with that have the same volume of the what? Substance. Huh? Weight of what? Which is the standard, right? Huh? Huh? Is that what you mean? Huh? There's something I want to talk about here. Listen carefully. I want to bring something home now, so that you don't get confused again with this issue. The basic thing you should know, one important thing you should know is that what is in the denominator and what is in the denominator must be what? Weight. It should be weight. For it to be dimensionless. For it to have no unit, it must be what? Weight. That's one thing you should know. Then secondly, another thing you should know is this. You know that if you do 18 grams over 18 grams, you are still comparing sulfuric acid with sulfuric acid. True of us? Are you there? You're comparing sulfuric acid with what? Sulfuric acid. If you use 18 gram, weight of equal volume of what? Well, if you take this to be what? 18 gram, you are comparing sulfuric acid with what? Sulfuric acid. But if you come here and say over 10 gram, this 10 gram is weight of water that have the same volume with what? Sulfuric what? Acid. Good. I said this, but this make more what? Sense. She's clapping. I know what I'm getting. Are you with me? See. Copy. Hello, listen carefully. Listen carefully. No matter how you see it, no matter how coming down. You solve question and get that solving question. Calm down, I'm coming. No matter how intelligent you may see me, I may look or whatever. Not everything. There are some things I'll be not only me. Try to question what things. Am I getting?
Yes, sir.
Until you get to level of thinking out of the box, not whatever I was said. You carry it like that. Who can what? Just like that, because your lecturer have said. You try. I'm not saying that you should be arguing with the lecturer. You try to reason it out. Am I getting? Try to reason it out, because the lecturer you are talking about, looking up to self, is not even perfect. He can do what? Make what? Mistakes. Even if you know that thing, you can still make what? Mistakes. Now, I brought these two things because this serves as a very important point to drive this thing home clearly. That's why I engaged her when she mentioned this. I brought the two of them. Please, when you are doing specific gravity, what should be under is the weight of that standard that have the same volume with the what? Substance in question. Is the weight of that what? Standard you are using that has the same volume with the what? Substance what? In question. Am I communicating? So here now, the weight of water that has the same volume with sulfuric acid is what? 10 gram. So what you are going to use is what? 10 gram here. So the answer is what? Gram will cancel gram. So no units again. The answer is what? 1.8. So what I said previously, that is the weight of sulfuric acid that has the same volume with water, is bar dash. Am I getting? Yeah. So this is what corrects. This makes more sense. You may not see this thing explained like this in what I gave you. That's why I say try to write that down things. You may not see it explained like this. In fact, it's not even explained there. Was it explained there? So please try as much as possible to catch up. There are people that once you start talking, they just switch off. It's not a good thing. Look, see how this one is sitting down. She has already switched off. Yes. Sit properly, okay? Switch on. Sit properly. Now, so please, is what? This. Now, someone said, solve question. But before we solve with more question, I want to point out something. So this thing is now equal to what? 1 point what? So specific gravity of sulfuric acid is what? 1 point. I want to interpret the meaning of this thing. I want to interpret the meaning of this 1.8. I want to interpret the meaning. When a substance in this case now, let's assume we are talking about solid and liquid now. For solid and liquid, our standard is what? Water, right? Right? Now, you are comparing them with what? Water. You are comparing them with what? Water. Since water is the standard here, the specific gravity of water is taken to be what? 1. Is taken to be what? 1. Specific gravity of water is taken to be what? What is this? Why okay. Specific gravity of water is taken to be what? 1. So any of these substances whose specific gravity is above 1 is taken to be what? Heavier than what? Water. Heavier than what? Water. Or denser. More dense or whatever. Heavier than what? Water. Now, so what it means is this, that sulfuric acid is 1.8 times heavier than what? Water. That's the meaning. That sulfuric acid is 1.8 times heavier than what? Water. So sometimes whose specific gravity is above 1 is heavier than what? Water. Then the one whose specific gravity is below 1, that is 0. Is lighter than what? Water. Lighter than what? Water, or less dense. So you can say that one is, let's assume, who are you looking for? So substances that have a specific gravity less than 1 are lighter than what? Water. While substances that have a specific gravity greater than 1 are heavier than what? Water. That's what I wanted to interpret here. Now let's continue. Please, there's something I want to point out. Most data, there's a table there that shows specific gravity of some substances. If you check the table now, you see specific gravity of some substance. If you watch now, water is highlighted there, right? Water is in between them. The one above water, if you see them, the one above water, 0.96, 0.92. Those ones are lighter than what? Water. The one below water, 1.03. Something like propylene glycol, 1.03. Clove oil, 1.04. Liquefied phenol, 1.07. Polysorbate 80, 1.08. These ones are heavier than what? Water. If you go up, you see castor oil, 0.96. Cod liver oil, 0.92. Alcohol, 0.81. Liquid petrolatum, 0.90. These ones are lighter than, okay, 0.87. These ones are lighter than water. See the implication. If you get liquid petrolatum or clove oil or castor oil and mix with water, those ones will be on top. That's the meaning. They will be on top, while water will be what? Because they are lighter than what? Water. If you mix water and kerosene, what happens? Which one will be on top? Kerosene. On top, right? Yes. Because it's lighter than what? Water. So the specific gravity should be less than what? 1. That's the implication. Am I communicating? Then what of, even though alcohol, you can see alcohol, does alcohol separate from water if you mix them? Alcohol and water, are they miscible? Are they miscible? Who said no? They're not. They are now. If they're not, why will you have 70% alcohol? That means water is the remaining area. So that means it has 70%, 70 mil, up to 100 mil in all. 70 mil linear alcohol. Then you mix it, they mix properly. So alcohol actually mixed with what? Water. If you go to the chemistry, organic chemistry of it, if you study the hydroxy group properly, you realize that it's what? Soluble. in water. Now, this is what I wanted us to talk about. But these things you see in this table is at a particular temperature. Please, very, 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 very careful about it. It's measured at a particular what? Temperature. Measured at a particular temperature. So the temperature, this thing you are seeing there, was taken at what? Room temperature. What is room temperature?
20.
What is room temperature?
25. Temperature in the room. Yes, right.
All right, let's continue. Let's continue. Start room temperature. Huh? Answer it. 22. Room temperature. 22. No, the one that is generally accepted as room temperature is 25 degrees Celsius. You can still see range, but the one that is generally accepted is 25 degrees Celsius. All right, let's continue now. Now, let's look at this question. After this question, we'll solve question. After that, we'll now go look at how to measure specific gravity using pycnometer. Pycnometer. Or density, or relative density bottle. P-Y. Huh? Let's figure.
I said
Now, don't worry. Let's do some calculation. After this calculation, now you appreciate it. You appreciate this specific gravity. Now, look at this question. The question says, if 54.96 ml of an oil, please hope you have corrected the mistake I made. Please correct it. That was a blunder. So correct it, okay? Correct it so you don't make the same mistake, okay? Good. Now let's continue. If 54.96 ml of an oil, if 54.96 ml of an oil weighs 52.78 gram. No sugar. If 54.96 ml of an oil weighs 52.78 gram, what is the specific gravity of the oil? You don't understand the question I'm calling. What are you saying? I'm too fast.
Weighs 5.7 kilograms.
Why are you not writing you?
I don't have pen.
No pen, not our. If 54.96 ml, if 54.96 ml of an oil weighs 52.78 gram, comma, what is the specific gravity of the oil? What is the specific gravity of the oil? Who can say for us? I share patience. If 54.96 ml of an oil weighs 52.78 gram, what is the specific gravity of the oil? Before I can answer, you can answer the question. There's something I want to tell you. Please, it is generally agreed. It's generally agreed that, hello, that 1 gram of water is equal to what? 1 what? Water, not only water. Only what? Water. So with this you can solve the question. Oh yeah. Oh yeah, come to the board, Chiamaka. Come here. Come. Come and solve it. You say you have solved it, right?
Is that right?
I want someone to come to the board and explain it for us. Yeah, it's not.
Explain.
Huh? Oh yeah.
Sir, we have to find this thing of water first.
The what?
I do not put it.
When you're giving a question like this, the first thing is to write down a formula first.
Yes.
It will guide you. Know the one they are looking for and the one you have already.
I don't have this water. Like,
Come here.
so, since 1 gram is equal to 1 gram,
You are told you are solving it for the class, not for me.
if 1 gram is equal to 1 ml of water,
You didn't measure water there?
No, we have to do it to write this.
No, we didn't now. We do it now.
Continuous. How many grams?
We do what?
We'll do this milk.
See.
Equal volume. They are going to be of equal volume.
This thing is for water.
I know now.
So I say that liquid now, only is liquid.
It's liquid now.
Water is liquid, so you
For it to be this volume.
Who will save us?
Benita, save us, please. You want to save us?
Benita, Fast. Okay, you're what we have to do, Brandon, yeah? Don't worry. When she's through, you come and solve for us. Fast. There's a step you missed. So, even though if you do that thing you are doing, you may get the answer, but it's not the right step. Sometimes it may not work all the time. That's why I don't want you to follow that step. Sometimes it may not work. That's why. Why do you call this thing weight of equal volume? That's what I want you to explain to me. Simple. Why do you call this weight of equal volume of water? That's what I want to explain. That's where the main work day. This is what I want you to explain to me. It's simple. You can easily do and get the answer. Why do you call this weight of equal volume of water? That's what I'm looking for. Oh yeah.
Sir, since 54.96 is the
Volume of what? Of oil.
It is considered that it's the same volume with water.
Uh-huh.
Then since 1 gram is equals to 1 ml.
You say what?
Since 1 gram
You
is
said
equals
that 15.96 is what? Oh yeah, now.
54.96 ml is the volume of the oil.
Okay.
It's considered the same volume with water.
Good, okay.
Then since 1 gram is equals to 1 ml of water.
Okay.
54.96 mil is equals to 54.96 grams.
Kono yaka biko. Kono yaka. Kono yaka na kono yaka. Obado yaka. This is what I want to hear. This is what I want to hear. No long story. This is what I want to hear. You were told that 54.96 mil of oil. So that means if what should be here is weight of equal volume. So that means the oil, the water should be the same volume with this oil. So the volume of water is now what? 54.96 mil. But for water, 1 gram is 1 mil. So convert that mil to what? Gram. You now have that weight of the water is now 54.96 gram. Even though this water and the oil have the same volume, right? But weight of water is now 54.96 gram. While the weight of the oil is 52.78 gram. Even without stopping it, you know that it should be less than 1. It's not true. Because the weight of oil that have the same volume with water is less than that of the water. Though they have the same volume, which is 59.96 mil. But water is weighing 59.96 gram, while the oil is weighing 52.78 gram. So you don't divide the two weights and get 0.96. So how can you interpret this answer? Which of them is lighter and which of them is heavier?
Oil is lighter.
The oil is lighter than what? Water. True or false? That's why the specific gravity of the oil is less than 1. Is it clear? Good. This is what I want to hear. Good. I like that. Yes. I think I'll stop here for today. Please solve the remaining one. It's simple. This one is combining avoirdupois. Yes, see it now. You have to do the conversions yourself. It's simple. It's simple. We have done it before. So it's not a new thing. All right, thank you very much for your attention. We'll stop for today. We'll continue in the night.
So I want to be